Good afternoon and welcome to this session of our TANGO Best Practices for Reliability Information Management. Our topic today is going to be best practice number 4, centralizing management of all condition assessment tasks. I'm Dick Hancock with 24/7 Systems in Knoxville, Tennessee, and with me is Forrest Pardue, our president at 24/7 Systems.
The two main goals that we're after, one is a shorter term, or I'll call it a weekly, monthly, quarterly type goal, where we really want to work to use our reliability activities to eliminate failures in service so we don't, suffer interruptions in production and higher maintenance costs. And a longer term area is increasing operating life of those assets by understanding where we have repetitive failure modes and taking on processes to systematically eliminate those root causes of failure. This best practices we're talking about today in centralizing your management of your condition monitoring task really is more associated with this first goal, eliminating failures in service. When we talk about information management for reliability, we're talking about really a cradle to grave life cycle set of information. So if you can think about from initial plant construction or capital additions or just replacements, each individual asset, and we're talking not only rotating equipment, but any kind of a repairable asset that might include electrical stationary things like transformers, certainly your distribution systems and your electricals, maybe structural items like tanks, piping, etc. So we're talking about the full range of those repairable assets. And there's a set of information that comes along from the time that asset or any of those assets are purchased to it goes into inventory. Maybe its actual physical location is initially in a store's location before it goes to a service installation. Then eventually at some point it finds a need to have to repair, either goes to an in-house or an outside vendor for repair. And then we repeat this cycle of being in stores, being in a service installation, being repaired perhaps many times, and hopefully we're seeing significantly long meantime between failures in these, but that's not the mode that many plants are still in today. Other types of information are as you capture all of this information that comes while it's in stores, like incoming inspections or periodic maintenance, like just replacing desiccant packs to keep humidity damage down, or turning shafts on motors that are in storage to reduce or eliminate false Brinelling, to the kind of information you generate during a service installation, this is where we're going to be talking about items, the best practice today, where you're doing condition monitoring activities, vibration analysis, infrared thermography, oil lab analysis or oil screening testing, online and offline motor testing, ultrasonics, other types of NDT, and walk-around inspections, which will be one of our topics coming up soon on the Best Practices series. So you generate lots of information during this installation phase, and certainly during repair, you get some real golden nuggets of information. What is it the folks see at teardown and inspection? That can be one of your best simple sources of insight into root cause failure mechanisms. Beyond what you see as the primary or secondary failure mode. And out of all that, then you get the ability to do reliability analysis in terms of looking at what your most common failure types are, what's costing you the most, whether it happens to be an individual location or an individual piece of equipment that seems to be the source of that repetitive failure mode. And again, the final stage in this cradle to grave is the point at which a decision might be made that that piece of equipment is no longer practical for rebuild or repair, and it goes to scrap. But in the meantime, we've generated this entire set of reliability information, and we're on item number 4 in a best practices series about how to handle that so that you can achieve those two goals that we talked about, eliminating failures in service and extending service life between failure modes of that equipment. And again, today we're going to be talking a lot about the condition monitoring activities that goes on primarily in a service location. Unfortunately, the typical state of that reliability information management today is what I call islands of information. It's just lots of different pieces, either in the native systems that are being used for vibration analysis or thermography, or the PDFs that might be being emailed or put on a website by your oil sampling lab, etc. And because they're all separate pieces of information, there's little to no standardization, even in terms of what the asset names are. And certainly then no integration, no easy way to see all of the available reliability information for any one asset or any one location at a particular point in time. And if I can't pull that information together because it's in these islands of information, then the results tend to be poor communication and accountability in my plant organization between what the reliability people know, what the maintenance planners, maintenance supervisors think they should be working on, and what operations understands is the real state of the world in terms of their asset health that they're depending on to keep the production going. And so when we talk about reliability information management best practices, we want to solve several of these problems that are on this slide. We want to bring it together and make it so that we can make use of all this information that's being generated. The first three best practices that we've talked about, pretty much common sense. It's a whole lot easier to be able to handle this information and not have islands of information if it's on a common database. And certainly today's web-hosted or cloud databases is a great solution for that. Best practice number two was clearly indicating that you want to deal in what we call actionable information, not the raw data. The organization that we're working with as reliability professionals, the maintenance department, the operations department, they don't understand the squiggly lines in a vibration FFT, or may not understand the radiometric images and all the nuances of infrared thermography. They want to know what the analysts that are using those technologies see in that information. They want to know their findings and recommendations, and that's what we mean by dealing as a best practice in actionable information, not just the raw data. And then the third item was the importance of not only tracking what's going on at locations, which, let's face it, in terms of practically all condition monitoring activities, is what I'm really working with. I'm dealing with condensate return pump 3 East and the motor and the pump that are on those base plates. I really don't know probably which individual motor, which tag numbered motor is on that base plate today versus 6 months ago. Same thing for the pump. But you also need to have information about both of those inventories of assets, both the location and the individual pieces of equipment. So you can, in the long-term analysis, you can do a lot to determine whether or not the problem, a root cause, might be associated with the location, maybe a bad base plate grouting job, or is it a piece of equipment that's carrying its problem with it as it migrates from base plate to base plate. So that brings us up to item number 4. The importance of centralizing management in all your condition-based assessment tasks. One of the drivers that I think we feel very strongly about is that with the growing importance of ISO 55000, any of these ISO standards really are focused on saying what it is I'm going to do, and then documenting and making it audible to make sure that I'm complying with what it was I said I'm going to do. And reliability information management is at the heart of that, documenting across the board what I'm doing in reliability as far as my intentions and my performance on meeting those intentions. Our focus today is on what we call condition assessment task. It might be what's in your vibration system as a vibration route. It might be your thermographer might call it a thermographic scan or a survey that he's going to do. It might be one-of testing that your PDMA guy is going to do with his electrical online or offline tester. But basically, you're defining what assets are going to be monitored by a certain technology at a certain interval. Is it going to be done weekly, monthly, quarterly, et cetera? And it's important to recall that when you get down to most of these systems, you actually are getting down to a component level, whereas a plant's EAM or CMMS work order system, in many, many cases still today, stops at a machine train or a group level and doesn't necessarily carry it down to the individual motor, the individual gearbox, the individual pump. That's where this condition monitoring is happening, is at the component level. And these are things, like I said before, not just rotating equipment. It could be electrical things like the panels and the buckets in the MCC. And then there's a route order that defines the sequence of inspection. We're going to talk about the fact that many of the native systems, for practically all vibration data collector systems, for example, will have a routing capability within themselves, but others, like some of the thermography and ultrasonic systems, may still not have that routing as part of task in their native systems. And we're going to really put this in context of an overall flow of I'm operating these tasks on the weekly, monthly, quarterly basis. The analyst is giving his assessment. That's that conversion of raw data into information, the actionable information that we believe is very important in the area of reliability information management best practices. And he's going to make determinations about what has been measured but is okay, doesn't have a problem, versus those that do have a reportable problem and need to have what we call a condition entry posted against that, and then the process by which those can go to a web-based integrated dashboard for the communication to those other departments in the plant that's so important. One of the things that's part of this best practice on centralizing management of these condition assessment tasks is the ability to create a standardized process. You're using a standardized way to name the actual task themselves. I'll be showing some things where a lot of plants will include the areas, the technology, and maybe even the interval time frame as part of the task name so that they're very clear to people, what that task is supposed to be covering. We're going to be talking about the ways in which today's modern technology, particularly smart devices, can be used in conjunction with the cloud database to give you the routing for those systems like IR or ultrasound that may not have that native routing in them. And very importantly, we're not just going to talk about how these tasks occur, but in the area of management, how do we use modern technologies like emails that can be triggered by a cloud database to let those people, let's say a maintenance or an operations supervisor in a utilities area, know that we're going to be doing a thermography scan in that utility closet or room next week. It's kind of important to know that all those systems are going to be loaded to make the thermography scan worthwhile doing. Once it's in this common web-hosted database as the location where you're managing all these condition tasks, it means that you have a tool for creating a standard entry of the information to tell the cloud database which components were measured but no problems were found, which ones were not measured because they weren't in operation at the time, for example, during a vibration monitoring task, and those that did have reportable problems and needed a condition entry. And as a result of all this and being in one cloud-based database, now you have a record that's auditable. It meets that ISO 55000 goal of being able to recall from 5 years ago or maybe 2 months ago because there's an insurance auditor sitting across the desk from you and he wants to know how current you are on the monitoring activities that are supposed to be occurring in that utility closet.
Assessment tasks really define your program. Everything, all of the assets, all the technologies that you're using should be encompassed in the assessment task. 55,000 says you want to define your program. Well, the assessment task does that. But then it also gives you the ability to report and assess your program. For example, a long time ago when we started 24/7, we only reported problems. And our clients came back and said, reporting problems is real useful, and an integrated condition report is great, but we really need to validate our program. We need to validate that we were there, we measured it, or we were there and we tried to measure and it was down. And so this gives us the ability to define our program, to validate all of our operations in that by technology and by component, and then provide something that is auditable, something that we can show and say that this is how management, this is what we've accomplished. We've done this on time and we've done what we said we would do.
Okay. So to start there, rather than stick with just PowerPoint slides, I'm actually going to go to active databases to demonstrate this more in real time. So here we're actually in our customer database for 24/7 who's given us permission to show what they're doing as part of these educational series that we're doing. And here in their task control panel, we'll see what's there as far as their task definitions. And they have a lot. A lot of those are thermography. You'll see here there's some infrared electrical. There'll be some vibration mixed in. There's a lot. I don't want to keep scrolling, so I'm going to use a different tool. I'll just go up here and type. Okay, so for route vibration, there's an interesting one. It looks like Eric set up something where he planned to do some one-off testing on. By the way, Eric Stevens is one of the reliability engineers at this sewer district, and he's actually going to this Thursday where he's talking about his experiences, particularly what's the focus of that talk.
He's going to be talking about remote analysis using TANGO, and so all his team, which is I think 6 guys, are working from home. And so they use TANGO and their software for the various technologies to pull it all together, make sure what tasks are being done, to report on those tasks and so forth. So again, his guys are using TANGO in a big way for working from home, and he's going to talk about that.
So again, just to get into the bones of a task, I'll go to this one that's more of a standing task. It's a sludge unloading area vibration quarterly task. I want to see the details. I look at the definition. And these are the important things is, again, we said in terms of we're mirroring what's set up in a vibration system if it already has routing. And in this case, when this one comes up, it'll show me that I'm defining not only the name of the task, but I'm defining the actual interval, when it was next due to start. They're overdue on the next due to start date, apparently. So anyway, this also gives accountability. It tells me that the assigned technician is Doug Little. This is his task. And so I know who I'm expecting to do this. It doesn't mean he's the only person that can do it, but this is the expected person who's in charge of what's in this task and when it's to be done. The other thing is we mentioned email communications. It's very important to be able to keep people posted about what's going on. So in this case, he's going to be notified a few days ahead of time before this task is actually going to show up. And again, I'll talk about assignments in just a second. Task group name, this one isn't being used here in MSD, but if I wanted to associate all of maybe I wanted a sludge unloading vibe task group. And I could then, that helps me pull up reports and things related to these common tasks in an easier way. It tells me the task is active, and this is the important point we've mentioned a couple of times where you're dealing with some technologies like maybe you have an older thermography system or an ultrasonic system that doesn't have routing as part of the native technology software. And you can actually set this up so that the route can be followed on a handheld phone or a tablet in the field, and the documentation of what you're measuring, whether you're finding it as measured no problem, or you can't measure it because it's not accessible, or you found that it needs a problem report as a condition entry, can all be done on that smart device. So that's the definition of the task, and then you're simply populating it with a group of locations which will be the actual component locations that are going to be covered by that task. So essentially, these tasks in the reliability information management system, it's mirroring what may be there in the vibration system or the infrared thermography system, but now it has achieved a standardized look and feel in terms of the way that it can be named. The asset locations, the component locations are all going to be pulled from a common asset hierarchy in the database, so that it doesn't matter whether I'm dealing with infrared thermography or I'm dealing with vibration or ultrasonics. I'm always going to know that this is the location I'm dealing with on this particular control center in the incineration functional area at the Little Miami plant. It doesn't matter if they're setting up and calling it something different in their own infrared thermography system or vibration system. By the time it gets into the reliability information management system, it now has that standardized name so that everybody knows what we're talking about. And again, one best practice that we talked about early is it's better to try to set these up. This happens to be a Maximo customer, so they've got some this Maximo ID string embedded in the component level of location. So once I have a task defined, then I'll end up with an assignment. I'll tie that either to the person we think owns that task in the long run, or if Joe happens to be on vacation this month, I may need to assign that to a different person. And I can do that. I'll do that through the create assignment tab. So here I see that Mr. Schneider, let's see, boy, that's out into November. So this is a task that's already been assigned, but it isn't expected to finish it until November of this year. Here's another one with it's an online MCA test that's to be done quarterly, and it's supposed to be done next due to start in October. So these are the actual assignments. And in order to assess, now we're getting to the point of the process where I described turning the data that's being collected by these technicians in the field into the actionable information. And I'm actually going to swap databases on you and go to, basically it'll be a enter edit assignment data function. I'm going to go to a database that we have as a demo so that I can actually put some information in without putting it into someone's real production database. So in this case, if I go to this hotline crane vibration route, and I want to do enter assessment data, once again, this process, taking the tools that are in the native software for either the infrared thermography, the ultrasonics, the motor testing, the vibration system, those are going to be done the same as those technicians have been doing since they started work in reliability. But what they're going to do is say that I understand as a result of, for example, looking at my exception report in a vibration system, that this particular trolley crane has a problem. It's in the 104 hotline on this trolley. He may say that this guy was measured and it needs a condition entry. And all he's got to do, and this process is going to be the same from this point, from this level, because again, standardization is an important function of making the information communicable to the rest of the organization. He's going to tell it what severity he thinks this is. We'll give it an emergency, just so that it shows up at a high level. If he has the authority to generate the work request for the work order, he may put those numbers in, or it is possible to have an automated link for those. In this case, let's say that he thinks he sees an early stage bearing. Well, that wouldn't be hopeless. And yeah, I'll give it a drive-in bearing failure as well. And outage, he could give you a long explanation of why he's seeing this in the waveform is impacting or whatever. He could also insert linked documents if he's got his, if this is a vibration route, he's probably got his analysis screen up on his computer, so he can do a screenshot grab of the FFT or the waveform or the trend plots, put as many of those in as he wants to document it, and he would save that. If so now that one's disappeared from the list, and if he realized that, okay, I couldn't do this measurement on the North Bridge crane because it was already down for repair. So he could mark that as down for repair. So now my list is shorter again. And if everything was measured, no problem found, I could just go up to the very top, say, no problem, nothing to report. And I have finished assessing this task. And again, this process is exactly the same, regardless of whether it's the infrared thermographer who was using that link documents area to perhaps link both his radiometric image and a visual image of a loose fuse connector, for example, in reporting the problem. But now all of these have been assessed, and I can close the assignment, and I will get a report that will be generated. But more importantly, this information has now gone to the integrated condition status dashboard, and an email could have been sent for the individual condition entry that we made. So we made a condition entry on this guy. That one could have been sent by email. And it's now part of the integrated condition status dashboard. So that's part, I guess that's the part of centralizing the management that deals with getting the task done and capturing the information from those tasks in a standard process, and then using cloud-based browser technology to be able to distribute this information to a kind of a dashboard like this, where we can see what our most critical problems that are being discovered by my condition monitoring activities are. And again, it doesn't matter, there can be multiple technologies reporting on a single asset. For example, on this particular cooling tower motor, we've got issues being reported by both vibration and thermography. The vibration guy is seeing a bearing problem. He's got his linked document from his analysis screen. The thermographer is a little more visual. I think he's found one of the real clues as to why this we may be having bearing problems on this motor with this coated fan end on the motor. But all of that information, again, is in a best practice scenario system. You're able to get that in one place so that it's easily viewable on a dashboard such as this, and then can be tracked as work orders are generated, work orders are completed, or what we call checked off, and then validation can be done by the vibration tech or the infrared tech or both, going back out and taking subsequent readings to make sure that they not only fix the initially reported problems, but that no new problems have been introduced. Okay. Now, one thing I wanted to talk about also is the fact that sometimes you don't complete all of these items. Maybe there are condition entries that are problems that are generated, and problems that are reported, or items that were measured, and it's on a 6-month task, and maybe it's not a good idea to be uncovered in your reliability activities for 6 months until that task is scheduled again. So part of the best practice on centralizing the management of these tasks have an ability to pinpoint those tasks that are not yet due to be done again, but that have discovered items that are either not measured or had problems on the last time that route or that task was done. And in our system, it's called reassessments. So they are listed as reassessments so that I can then make a decision as to whether I want to assign this electrical offline test again to go back and cover these 9 items before it's due at the end of the year, in between Christmas and New Year's. And I don't have to go through all of the items on the task. I only go through the 9 on that task that had problems or weren't measured. And like I said, this is especially helpful where you have routes with long intervals. We have some customers with infrared thermography routes, for example, that are 365 days in duration. And these are contractors that are coming into the sites and doing these several times a year. So they don't want to have to weed through the entire task each time. They want to know what it was that they haven't covered, haven't been able to mark as measured no problem, and do a smaller list of items each time they come back to the site. And that's what the reassessments are good for. Any comments on that, Forrest?
No, it turns out the reassessments are important on any sort of routes that go over maybe 30 days. You know, if you're doing it every 30 days, you don't really need to worry about trying to catch it before you do the route again. But 90 or 180 or so forth, yeah, it's nice to work down the items that are out of bounds or haven't been measured during that interval, so that by the time you get to the end of the interval, you've gotten everything, and now you're ready to reassign it again and start again.
All right, Ian, we're more in we've talked about managing these tasks, creating the standardization amongst the different technologies and how the tasks are defined and the assessments are done and that information gets presented. But now let's talk about managing how well the tasks are being, what am I getting done, particularly that part of ISO 55000 that talks about the ability to say that I've documented everything I'm doing and make it auditable. And those reports that I mentioned, for example, they don't just go away. They become part of the history in the cloud database. So, for example, here, it'd be very helpful if we're looking at a site that's a Foundry site, and we're going to go all the way back to 2016. Maybe there was an insurance claim that had been done, and the insurance adjuster is coming in wanting to know, were we on top of the items? And now we see that, in fact, yep, they did this task. It was back between May 18th and May 26th of 2016. There were 2 items that they had to skip because they didn't have time. But if I want to see that list, there it is. On the other hand, if the thing the inspector is asking about is one of these, then we've got documentation that's when we measured it. It was measured by Josh Tumblin, and he documented that it was no problem, nothing to report. So, we've covered that auditability requirement.
Oh, there's another good way to do that if you go to the tree. And just pick one that's in the integrated condition report, and then go to
anyone.
Just I think anyone's fine. Tree. Now go to the motor and do a pull down, and other reports. And I want to do
severity.
Condition assessment history report.
Right there.
All right, so this is every technology that's measured it and what was found. So there's lots of no problems measured. So if you look at this is since 2012 they've got a record. Every time they measured it and what was found at that component.
Again, we're kind of working our way back. One of the other important tools is just from a management of my program itself and my personnel, is how am I doing on adhering to the schedule? Are we doing what we said we were going to do as far as the task on time? And there's a condition assessment task metrics. This is back at the municipal sewer district in Cincinnati. So here, by default, it comes up by, I think, alphabetical order of the task name. But if I want to just find out where my...
And it's got an interval.
Oh, okay, right. And this date is for the previous year, effectively. In this case, I'm running 100% adherence on a lot of these thermography routes, and a lot of electrical offline and online. And they run lots of routes, lots of tasks. There's some vibration. If I just wanted to check the vibration, guys, I could come in once again and filter. And again, they've got a lot of 100%. But if I'm a reliability engineer, I'm probably not all that worried about the 90, 88, even 75%. The ones I want to look at are down here at, if I'm only actually meeting my goal 37.5% of the time on this quarterly task for disk filters vibration routes, maybe I need to consider whether that's too often to be doing it. Is it a manpower shortage? You know, what's the reason that these are down so low? I know which task to focus on to see if I need to get that number up, or if I need to maybe change the setup, the interval on the routes on the task.
And if your program, it really isn't challenging itself to go in and look at this sort of thing, it should be.
Well, again, it's false assurance if you're bragging and feeling comfortable because you got 10 vibration techs that are covering lots of ground, and you got 3 infrared thermography techs. But if in fact you're not getting all the locations covered that have been a result of your RCM study as the critical assets that need to be done on a quarterly, semi-annual basis, then it's a false assurance. And so toward that end, there's one other important report.
While he's getting that, I will say that a lot of times this is a set of numbers you need to report to management. At least the overall is what is your compliance on getting the routes accomplished, and what is your compliance on getting the points measured, no problem, resolved.
Which we're going to talk about in just a second here. But first, we're going to say, how do I uncover the details that I need to really take a look at? So we'll just take a look at year to date for the sewer district on any of the technologies, and we're going to focus on what's on a task. We don't want to know about those locations that haven't been deemed as needing to be on a condition task. I now have a detailed list which I can throw over to Excel if I needed to, wanted to sort it further. And I get the ability to look at by individual technologies, but these are down to the area, the plant, the functional area, the asset train, and the individual compartment, and which date it was last measured. This one's never been measured as far as it's on a task and hasn't been measured. This one's been not quite a year, 2/3 of a year, and hasn't been measured, etc. I can also then sort by which ones were okay the last time they were measured. I could type in, if I wanted, once again, I wanted to separate it by vibrations. Apparently doing pretty good. I've only got 3 items in vibration that are in this not measured for this year, whereas thermography's got a lot. So,
but again, you got 2 of those items that haven't ever been measured. So either they need to go, these guys, this program was started in 2012. Either these locations need to be taken off of the route if they're never going to be done, or somebody better figure out what the problem is. Are they guarded? Are they shielded? Can they find them when they're running? I mean, there's lots of reasons they may not have been done. And maybe they're critical equipment and you really want them done, so there's some questions to answer there.
Actually, one of the drivers behind this very report was the sewer district. They were finding that in a lot of cases they had technicians that were making the trip to go out to these treatment plants, and then the operators were not giving them access to the pieces of equipment. So when they first started this report, their real goal was to be able to have a good document that they could take to management and say, look, all these guys at XYZ plant are letting us get to the piece of equipment and we're getting it monitored on time, but look how many cases or situations we have at the ABC plant where it's measured, no access allowed. And they use that as a tool for getting management support to help convince the ABC plant personnel to cooperate a little better. So the report Forrest is talking about, though, and I'm going to run this one, we'll run it at the just one of the levels. If I want to see what this particular plant is looking like, this is I call it a higher level management report. This lets us look at, in this case, since I'm filtering it by component, we're going to find the answer to, in a graphic report, showing which individual assets were measured last by which technology and what was the condition, what was the state of health of that piece of equipment when it was last measured. So they're doing this many different technologies, and I now see that at this little Miami plant, they're covering 145 locations that were assessed. Out of those, 95% were measured no problem. 2% had condition comments. Something might have been developing or deserved a comment, and a little less than 3% were in a reportable problem. So then the next thing I want to look at is, okay, April 9th, that's probably pretty current. A year ago almost, in 2019, that's getting a little dated for vibration information probably. And here's one, for example, 2018. So this is a good way to get a high-level view, particularly if you use the filtering that we walked through. You can filter it by individual plant first, find out which plants are having more, I'll call them outdated measurements, long in the past measurements, particularly if they happen to have a problem when it was last measured, versus plants that are kind of green across the board. And of course, that's what the individual plant operators like to see. But it also gives me that reportable metric where they can see whether my progress is improving or decreasing, so that out of all of these technologies, in fact, this sewer district at the Little Miami plant is getting 97% done on getting things or having them measured. Whether they're current or not, you'd go to one of those other reports.
While you're looking, run this report for the whole database.
Okay, Forrest wants me to run it for the whole database, so this one's going to crunch everything they're doing at all 7 plants.
And again, I find that management really likes this little top area of the report. You could snip it out and put in your email or whatever, but they like to know how many components have been measured and how many are good and how many are not so good by plant and total for the company. And so this gives you a good measurement or a good set of metrics that management really likes to see.
And like I said, the report I was thinking about earlier is when I combine that information from a management judgment, the reliability manager judgment, if I go back to my condition task metrics report, and that tells me whether or not I've actually done these tasks 100% of the time versus 33% of the time, then I get an idea of if I'm doing a good job at 90% or better on my task completions, and I've got a 95% overall in green condition on my asset health report, then I'm up to date on my measurements, and I don't have a lot of problems that are being reported. And once again, just as a tidbit, this kind of goes back to something that we got from one of our good customers 15 years ago. They talked about the progression of their program from the early 80s and how when they first started with getting technically proficient and then proficient at communicating and holding people accountable for following up on the condition reportable actionable items from condition monitoring, they found that initially they were doing 20 to 30% of the individual components they were monitoring back in the 80s and 90s were having reportable problems. When they got efficient, both at being technically proficient at the technologies and good at reporting the information and holding people accountable, they drove that down to 3%. And so that kind of, I don't know if I can call it world class, but it's certainly good performance when you see that kind of an improvement and change by making sure you're using the information that you're paying to generate. So I think with that, we're back to open it up for any questions here on this best practice idea of centralizing the management of your condition monitoring task. I certainly appreciate your time this afternoon, and I invite everyone to, in about 2 more weeks, it'll be the include walk-around inspections in your reliability program. will be our next topic on reliability information management best practices. We hope to see you then. Take care.